So with chemistry being a measurement-driven science, we need to understand what these things called Sig Figs are, significant figures. Some people call them Sig Digs, significant digits. But essentially, every measurement has an error. And so when we do calculations in chemistry, we have to be responsible for that error and report our answers accordingly. So in this little paragraph, it's talking about a thermometer. So if we look at a thermometer, it is easy for you to guesstimate the temperature that's being reflected there. And so I can look at the Celsius scale. So when I see the temperature here, you can see that it's budding right up on that 25 degree mark. But I don't just want to say it's 25 degrees Celsius, because that would mean you're reporting in science that it's somewhere between 24 and 26, because you're telling that there's error in that one spot. We can read a thermometer much better than that, so I want to be saying that it's 25.0 degrees Celsius, and that way I'm saying it's between 24.9 and 25.1, and that's a much better reflection of that temperature reading. So what we need to do then is take that information, understanding the error in our numbers, and then work with these things called Sig Figs. So the first thing to understand is that pretty much the game of Sig Figs is all about the zeros, because rule number one here says every non-zero number is significant. So if there's a measurement and it's a non-zero, it's significant. So 24.7, 714, those measurements have 3 Sig Figs. So what about here? 1,628 feet. That would be 4 Sig Figs. Now if we end up having zeros between non-zeros, which I like to call a zero sandwich, then those zeros are significant. So example here, 7,003 kilometers, or 40.79, those zeros are what we call significant. So in this measurement here, 20.074 miles, that would be 5 Sig Figs. Those zeros in between the non-zeros are significant. Now our next rule here kind of gets at, hold on. Like I said, our next rule kind of gets at what does this word significant mean. Zeros in front of non-zeros, they're not significant, but as it says here, that doesn't mean they're not important. They are placeholders. They're signifying the size, the magnitude of the measurement. Zeros in front just mean like it's a very small number, and you just kind of ignore those zeros, and this is the part that was actually measured. So 0.0071 centimeters, their measurement occurred down at the 1,000th and 10,000th place. So when we have zeros in front, like in this measurement, 0.00463 grams, there are only 3 Sig Figs, 3 numbers that were actually involved in the measurement. The zeros are just placeholders taking us to the measurement. Same thing with these naked zeros. If you have zeros at the end of a measurement, they're not significant if there's nothing around them. Again, they're just placeholders. 2,700 miles and 440 minutes. They only have the 2 Sig Figs. 2,700 miles, that means the measurements, somewhere between 2,600 and 2,800. So that's like a very rough estimate of miles. And so those zeros are just kind of placeholders. And so same thing here, 3,600 inches, that would just be 2 Sig Figs. Sorry, I thought I paused the video, so there's a little lull there while I cleared the ink off. But our next rule says that if we put a decimal point with those zeros at the end, then yes, indeed, they become significant. 43.0 meters. Now we're talking again somewhere between 42.9 and 43.1. Someone went out of their way to make sure that we had that point 0 there to signify how good the measurement is. Like here, 425.00 kilometers, there's 5 sig figs. Someone measured down to the hundredth of a kilometer. If we have zeros in the front and back, the front ones are never significant. Those front ones are always just placeholders to take us to the measurement. But the ones at the end, they are significant. Those are, again, are included in the measurement. So 0.002450, the guys in the front know, but 24500, that's 5 sig figs in that number. One of the ways we can get rid of the bad zeros, the confusing zeros, is by doing scientific notation. When we chop off a bunch of those zeros, then what's left in the scientific notation is always significant. The times 10 to the stuff, those are the zeros we chopped off. So here we have 6.705 times 10 to the 8th kilograms. So there are 4 sig figs in that number. Our last rule here, there are times when we say there's an unlimited number of sig figs in a measurement. One instance is when it's a count. We assume things that are countable that we can count correctly, like 25 students in the room or 126 tables in the student center. The other time is when we are talking about a definition or a fact. 60 seconds in a minute. We don't say that there's 1 sig fig. We say that, that's just a fact. There's no error in that measurement. 100 centimeters in a meter, etc. So what you want to do now is try and attempt these 9 measurements and tell me how many sig figs are in them. And over here on the side, you see I put a little picture of some highlights of those rules. But give it your best shot for those 9 measurements and answering how many sig figs there are. And you can pause the video and do that, and then restart the video and I'll show you the answers. So our first measurement there, 123 meters, that is definitely 3 sig figs because they're all non-zeros. Next door, 0.123 centimeters, the 0 in front is just cosmetic, so again, just 3 sig figs. 40,506 grams, those are our 0 sandwiches. They're between non-zeros. So all of those, all 5 numbers in that measurement are significant. Now D and E, we see the same quote-unquote number, 98,000 kilometers. The first one, though, there's no decimal point, so that's a very rough estimate. That's just 2 sig figs. Someone's saying it's between 97,000 and 99,000. Whereas the next measurement has 5 sig figs because of that decimal point. Now someone is saying, no, I went all the way to the 1 spot, so this is between 97,999 and 98,001. Letter F has scientific notation, so definitely those 3 numbers are significant. I wonder what's under the box for letter G. 22 people, that's something I can count. So that is unlimited number of sig figs. 25.0, again, 0.0 saying I measured there, so that is 3 sig figs. And then letter I, we've got zeros in the front, a 0 sandwich, and a 0 at the end. The front ones, never significant. Sandwich, yes, and at the end, yes. So here we're looking at 4 sig figs. Hope this helps. Hope you feel confident about sig figs. Sorry about some of the little errors in the video, but hey, I ain't perfect. All right, have a good one.